Welcome to EDU World Space.
Problem 3.98. In this problem, we have to find equivalent force couple system at point O. So here the force, let's say that this force is P of magnitude 110 Newton is acting at this edge. Let's say this edge is B. So we have to find the first of all the moment, equivalent moment at point O and equivalent force at point O. For that, we have to resolve this force into its horizontal and vertical component. Since this force as given in this problem is in the plane YZ, means it in the plane parallel to the YZ plane. So its component will be, first this component is going to be along the Z direction and its vertical component will be along Y direction. So we can resolve this force into its horizontal and vertical component. So we can write this force to be 110 cos, this angle is 15 degrees, so this angle will also be 15 degrees, so cos 15, and this is along k cap, and the vertical component is 110 sin 15, and it is along minus j cap. So the force that is acting at point B is minus 28.5 j cap plus 106.3 k cap. Since in this system only one force is acting, that's why this force will also represent the equivalent force at point O. So this is the equivalent force at point O. Now talking about the equivalent moment at point O, we can calculate this by using this relation, that is position vector of point B, that is a point of application of the force with respect to the point where we have to calculate the moment multiplied by the force, that is, let's say P vector here. So since the coordinate of B is not known, so we can calculate the coordinate of B by using this diagram. Since in Y direction it is at 150 mm, so its Y coordinate is going to be 150, and let's convert these units into meter. So coordinate of point B will be, so its X coordinate we have to calculate, and Y coordinate by directly observing this diagram comes out to be 0.15, and Z coordinate we have to calculate. Now this 220 mm is the length given in this problem is of the side AB. So it can be resolved in its X component and Y component. So if we resolve this, if we drop a perpendicular on this line, so this length along the X axis comes out to be 220 cos 35. So its X coordinate is 220 cos 35, and Y coordinate, since it is in negative direction, so it comes out to be minus 220 sin 35. Now the coordinate of point B is known, so we can now calculate the moment about point O, which will be position vector, that is 220 cos 35 I cap plus 0. Alright, we are actually here doing a mistake, that these units are, this was in meter and these two units are in mm, so we have to divide it by 1000. So we have to modify this statement here, and this statement will be, now it will be 0.22 cos 35 I cap plus 0.15 j cap minus 0.22 sin 35 k cap. Now we have written the position vector of point B with respect to O, and we have to cross multiply it with the force vector that is given here, that is minus 28.5 j cap plus 106.3 k cap, and obviously its unit will be Newton meter. Now we can solve this by using determinant method as I cap, j cap, k cap. Coefficient of I cap is 0.22 cos 35, coefficient of j cap is 0.15, and k cap coefficient is minus 0.22 sine 35. Now coming to the force vector, the I cap coefficient is 0, J cap coefficient is minus 28.5 and K cap coefficient is 106.3. Now we can expand this expression and we can collect the coefficient of I cap, J cap and K cap. So coefficient of I cap will be, if we expand this along I cap, so it will be 0.15 multiplied by 106.3 minus 28.5 multiplied by minus 0.22 sine 35. So this is the coefficient of I cap. Now talking about the coefficient of J cap, it will be 0.22 cos 35 multiplied by this element, that is 106.3, minus the second term will be 0 since 0 is going to multiply with the term. Now talking about the coefficient of K cap, it will be 0.22 cos 35 multiplied by minus 28.5, and the second term is going to vanish since one term is going to be 0 here. So if we solve this by using calculator, so the moment about O comes out to be 12.35 Newton meter I cap minus 19.16 Newton meter J cap minus 5.13 Newton meter K cap. So this is the equivalent moment about point O for this system, and equivalent force about for this system about at point O we have already calculated here. So this is the final answer.